All right, so looking at the perpendicular bisectors, we have just the perpendicular bisector itself. It means it's a segment or line that's perpendicular to another line or segment. Well, it has to be perpendicular to a segment. And it's going to form the right angles, and it's going to create two congruent segments. The perpendicular bisector theorem tells us that if a point, if a point lies on the perpendicular bisector of a segment, then it is equal distance from the endpoints of this segment. So as you can see here, if CD is perpendicular to AB, and AD and DB are congruent, then AC and CB are also congruent. There's more. And then the converse of the perpendicular bisector theorem says if a point is equal distance from the endpoints, then it is on the perpendicular bisector of the segment. All right, so we'll look at example 1 here first. It says find X, and they give us this picture of the triangle with a perpendicular bisector. And it's asking us only to find X. And the theorem says that if I have the perpendicular bisector, it bisects this segment, and any point on this that goes out to the endpoints of the segment will also be what? Congruent, or equal distance is what it says, right? So that means this piece is congruent to this piece, and that means those expressions are what? Equal. So that means I can say 13x minus 48 is equal to 7x plus 24, and now I can solve for x. I can subtract 7x from both sides. I'm left with 6x minus 48 equal to 24. I'm going to add 48. Y'all don't need those stinking calculators for these numbers. I get 6x equal to 72. And when I divide by 6, I get x equal to 12. And that's what they were asking me for on that one, right? Questions? Okay, so let's look at the next one. I'm hungry.
Me too.
Okay. So this time they tell us that D is equal distance to E and F. So what does that make DG? What does that make DG? What is the name of DG now? If D is the same length at DE is the same length as DF, what is DG? What kind? A perpendicular bisector. And so what does that mean about EG and GF? And so those equations are equal. So 14x minus 37 is equal to 2x plus 11. So now I can solve for x. I'm going to subtract 2x from both sides. I get 12x minus 37 equal to 11. I'm going to add 37 to both sides, and I get 12x equal to 48. And when I divide by 12, I get x equal to 4. Is that what it asked me for?
No.
No. Who did it ask me for?
EG.
So that means I've got to take 4 and plug it in for x. So 8 plus 11 is 19. So EG is 19. Questions? None? All right. You try this one. Find AB given that information. The trick here was that they are not asking for a small piece of the segment. They were asking for the entire segment, right? So you had to make sure you caught that. So they asked for all of AB, and you could have just found one of the segments and multiplied it by 2. That would have worked, yeah. Or do it like I did. I found both just to make sure. Those of you that made both, though, you should get the same number, right? Mm-hmm. Something didn't come out the same. That would have been a trigger for you to check something else. So my x was 14, but my answer for AB was 118. Any questions? None? All right. So we're going to move on to the angle bisectors. Angle bisectors. Does everybody have this problem? Good? Okay.
Wait, we're in 5 now?
We've been in 5. No? Haven't we?
No.
You just haven't been here, so you don't have the new thing.
I have? Okay.
All right. So angle bisector. So our angle bisector is, it could be a segment, it could be a ray, it could be a line. But it cuts an angle into 2 congruent angles. The angle bisector theorem says that if you have a point on the bisector of the angle, then the point is equal distance to the sides of the angle. But the point you have to make clear is that if I'm going to check their distance between the sides, you have to make sure the lines are perpendicular. That's how you make sure you're going the straightest point between 2 lines, right? And so, as you can see here in the picture, AD is bisecting the angle BAC. This is where people are having a little issue today. The angles, when they have more than one angle at a vertex, it has to be named by 3 letters. Everybody put your pencils down. I want you to look at that picture under the angle bisector theorem. I have the angle BAC. That's the whole big angle. Does everybody see that? And then I have BAD, that's the small top angle. And then I have DAC. All three of those have the vertex of A. Does everybody agree? Make sure that you know what it's looking for when you look at these. Okay, you can continue writing. All right, and then I have BD perpendicular to AB and DC perpendicular to AC. And because all of that happens, then BD and DC are congruent. They're the same distance. What it tells me is that point D falls on an angle bisector. Does everybody have the definition of angle bisector down? So I'm going to go ahead and pull up the Converse angle bisector theorem, and it says if a point is on the interior of the angle and equal distance to the sides of the angle, then the point is on the angle bisector. So here they've marked for me that BD and DC are congruent, they're the same distance, and that AB is perpendicular to BD and DC is perpendicular to AC, and that makes AD the angle bisector. It bisects angle BAC, creating the two congruent angles. Alright, so looking at the first example here. We're going to find X, and they give us an angle bisector. The reason I know it's an angle bisector is because it cuts the angle in half, and a point on it is perpendicular to the outside. But the reason I know this is an angle bisector is because these two angles are congruent. Now, because I know that it's an angle bisector and these lines go out perpendicular, what do I know about those two segments? They are also congruent. And if they're congruent, the two expressions are equal. So if I know they're equal, I can set them equal to each other, and I can solve for X. And I get X equal to 7. Is that what it asked for?
Yes.
Yes. So I'm good. So if I have an angle bisector, the side of the triangle that goes out to the sides of the angle are congruent. Is everybody with me? Okay, let's look at the next one. Take a second to draw it. All right, so I have example 4 here. I have to find AD, the length of AD. So they have an angle bisector here, BD. How do I know that that's an angle bisector? Splits the angle into two congruent pieces, right? That marking says they're congruent. So if this is an angle bisector, and from point D I go out here to A perpendicular and to C perpendicular, what do I know about these two segments? They're congruent, so I can set them equal to each other. So I have 13x minus 4 equal to 8x plus 11. So I'm going to solve for x first. So I'm going to subtract 8x from both sides. And that gives me, what, 5x minus 4 equal to 11. And I get 5x equal to 15. And x equal to
3.
Is that what they asked me for?
No, ma'am.
They asked me for who?
AD.
AD. So I've got to take and plug in 3 times 13 minus 4, and that gives me 35. So on this one, it's very interesting because I do also have congruent angles. So they could ask me something about the angles also, right? Not just sides. So let's look at one of those. You try this one. Find the measure of angle FGA. Are you still working on this one?
Tomorrow to
Here is the final
Also, bus
piece.
46.
Making sure you're getting the
You write
whole
bus
angle, not just a
46.
piece of the angle.
It will be held until 44 can return, and 44 should be back between